Good morning or good afternoon, folks. How are we all doing now? Can you give me a thumbs up if you can all hear me and see me? Oh, second. Okay, now you should be able to see me. Excellent. Very good. Good. Oh, is I'll just drop down into our area and now, folks, is I just opened the slides and I just wanted to quickly check if the quality is good enough and up and running as such. Just bear with me now. And Now, how is that? Are the slides very visible? Everything okay?
Yeah.
Yeah,
Yes.
perfect, perfect. Okay, folks. We'll continue from where we left off. I put up what was called part A of this lecture on project management and a deeper view, bringing you down into the some of the nuts and bolts, as we say, the basics of this. And we stopped at this point last week, and I said I'll continue on. So what I'll most likely do is I this video, once this is recorded, I'll upload this as part B. Either that or I'll appendix it or merge the two videos and just put a timestamp in it, so it's on YouTube you can jump from one to the next directly. So in this context, so the moving on, we'll have a look at the role of the project manager. And as I said a number of times, that the project manager being the person responsible for delivering the goals of the project perfectly, so, and the figurehead and the leader and team leader, all these roles combined into one. And I did mention that we'll have a quick look at leadership on another video. I'll provide a video for you that I've already discussed leadership and some of the qualities and attributes, characteristics of effective leadership. I'll make that available to you early next week. As you know, next week I think is the RAG week. So essentially we don't have, there won't be any online lectures per se. I will record some stuff and make it available to you. I think the idea was that to give you guys a bit of a break from this continuous online as well, and probably ourselves, but not so much so since we're going to record anyway, and make material such that you don't have to be sitting in and attending lectures all day every day. So I think that's the plan for next week. I'm not sure if you've been told that or anything like that, but in any case, I'll make some videos available next week on more material for you, and that you can look at your in your own time, or indeed carry on your project work. So moving on anyway, project manager person, so, and project time and cost and scope. And so time, cost and scope, you have the project manager who's there to oversee, control and monitor these three elements with the project team: time, cost and scope. They're the that triangle of concepts are the our projects. So you have so much time, you have a budget, and you have the scope. The scope are the features, the requirements, what you've agreed with your customer, your client, and so on. And oftentimes you'll hear the expression scope creep. That's when things start to get more and more bits being added into a project, and that's one of the biggest risks and threats to completing a project successfully. That's not to say that we don't allow scope creep. Of course we do allow, but in a managed way. And I'll introduce you to a couple of concepts later on when we're looking at some examples of the methodologies that we've used. So again, this is just another graph highlighting those three interrelated constraints, and they're most important, because absolutely, if scope creeps out, it's going to take you longer and it's going to cost you more. And if you want to reduce the cost of a project, oftentimes you'll definitely reduce scope. You might not necessarily reduce time. And likewise, if you want to compress a project or shorten the project, you have to reconsider some of the deliverables, features maybe. So essentially you're reducing scope, and you'll also potentially reduce cost. So all of these are intrinsically linked. That's important. And once you're happy, you know that there's for every action there's an equal and opposite reaction and reaction, so to speak, the double whammy. So the discipline project manager. So essentially, what we need to do is try and break everything down into what we call work breakdown structures, and then we have precedence relationships and time estimates. We have Gantt charts. We have network diagrams, critical path method, which I mentioned before. You know, getting the sequence of the most important items to be delivered in the sequence. Cost and time trade-off analysis, which is essentially the reduction or increasing of scope, as we've just seen there. PERT charts, and then resource management. So these are the tools available essentially to a project manager to break everything down. So let's start looking at some of these. The work breakdown structure. So an approach that defines a project in terms of its sub-projects, tasks, and activities. So you want to build a car, you have the final car, what, you know, in terms of your output, your deliverable, main deliverable, but you break that down into sections. So down into, you know, the engine, and then breaking down the engine into smaller components, and then you break it down to a level that either a piece of equipment or a person can make, manufacture, build, or construct. So that's what we aim to do. So, you know, an engine will be a deliverable, but that deliverable is the work of several other areas. You know, people making the head block, making the pistons, and all the other components that go into the engine. That's one way of looking at it. I think for simplicity, I'll stick with the house building as such. So you have a finished house, you break that down into, well, what has to be done? We have to bring in block layers, special skills. So people that can actually build blocks and put in a foundation, build blocks. Then we'll have a plasterer, electrician, and a plumber, and a roofer, generically speaking. And then you'll have painters and various decorators and so on. So you'll have all of these skills and various pieces of equipment that you need to use. But the bottom line is, how many? You couldn't put 100 men building one house. It would be impractical. But you might need maybe 5 men. That might be the optimum number of guys that you will use to build do the block work, for example. So how many guys? And each of those will be expected to lay maybe 100 blocks per day. So that's 500 blocks if you have 5 guys. So that's the simplest work breakdown structure. So person 1, 2, 3, 4, and 5, you have a target of 100 blocks per day to build in here, and coordinate that into the walls and so on. That's a work breakdown structure, breaking it all the way down. So at the end of the day, you can stand back and say, well, there's the deliverable, that wall, or these 3 walls of the house. That's what we aim to achieve today. And we took 5 men, and this is how they were organized to build those 3 walls. Perfect example of breaking stuff down into work breakdown structures. So activity, the smallest package that can be assigned to a single person, worker, or a team itself. So that team of 5 workers, then each of those 5 workers can have, you start there, you start there, you start in the middle. We'll do all our calculations and we should meet. You 2 guys, one guy here working on the side walls because they're smaller and on each side, and 3 guys working on the long back wall, for example. But you see what I mean? It's simplifying it, but nevertheless, once you get your heads into that space, break it down to small, manageable pieces, then you will get the work done. And it's only a question of you have more oversight, it becomes a lot clearer, and the deliverables are much easier to monitor and control. And oftentimes you might say, will you 5 guys, will you build that wall, those 3 walls? How long will it take you? And they say, well, we'll probably get it done in a day if we have good weather and all that sort of stuff, and if you keep us with all the blocks and you give us the cement, we 3 of us can deliver this in a day. You as a project manager could walk off that site because you can trust these guys. Now there's a lot, what I'm saying right now is very, very important. You could walk off that site and go on to another house and organize another group of guys to be doing something else, because you can trust these guys. You know they're good at their job, you know that you have everything in place, cement blocks, and you have the 5 guys there. The only thing you can control obviously is the weather, but let's assume that the weather is good, you're doing it during the summer months and so on, and you can trust those guys to deliver. And and sometimes it may be a case that you might not be on the site, and the guys themselves say, well, listen, guys, we have to build these tree walls today. We look at the original plan, we'll go off and do it. And so that's where we start to introduce the concept of agile, because these guys, agile development, which you would hear oftentimes around software, but has mitigated, or it has moved out into all realms of work virtually. So you'll have agile this, agile that, and lean agile, and it's because people are able to break it down. They know what they have to do, they go off and do it, and they do it within the specified time. And so as a project manager, you can come back and you see, well, the tree walls are built because these guys knew what they were doing, and so on. That's very important in terms of what I'm saying, as to how this all has evolved over the last 20 odd years in terms of agility in project management. Sometimes companies use this concept, oh, we practice agile project management, and actually don't understand what they're talking about. They jump onto the words, the phrases, the concepts, and they don't have a depth of knowledge or understanding of precisely what they're talking about. But you'll see here, but in down here, it's essential that care is taken to develop a realistic work breakdown structure. And this is the point I was making. If you wanted to have these three walls, there's no point in putting 50 men on these three walls in a house, because they would be getting in each other's way. Or you wouldn't break down and say, well, I want, let's break it down into, you do those 2 meters, you do those 2 meters, and you do those 2 meters, and you do 3 meters. And so you don't break, that's overkill, if you follow me. So say roughly, how many blocks can they lay per day, and let it work at that. There's no point in measuring it down even further. So that's why it's essential to get realistic. Don't go too high with numbers and so on in terms of over resourcing it, and then don't break it down to levels that are not necessary, going way too deep, as I said, down to a task that a single person can do and within their competence and ability levels. And here's an example of a work breakdown structure, if we take this house example here, you have project A or project B, and then you have task A in project A and task A2, and then you have A1. So you're breaking it down until you see all these little packages in project A up here. If you follow that trend here, and I'm in opposite directions with my screens and cameras, but that breakdown here, and similarly you can do the same for B and so on. And so the precedence relationship analysis, it's a little bit of an overstatement, but it's still an important concept, particularly when we look at the critical path approach. And then identify the relationships and the sequence of activities within a project. So what must you do first? So for example, sticking with our house, you have to put in the foundations. That's first. And then you build the walls. And then you put on the roof. And that's the precedence. This sequence of tasks have to be done first, then the walls, the second sequence of tasks, then when you put in the openings for doors and windows, and then we build the roof when we have the 4 walls to support it. And you might say that's common sense. You would be surprised. Now, building the roof on the house is the sequence, okay? You could, for example, save some time by pre-constructing parts of the roof while you're building the walls. There's no point in starting earlier. You'd have stuff lying around and might get damaged, stolen, whatever. But let's just say you can pre-construct some of the wooden frame for the roof while they're building the blockwork at such a time when the walls are ready. Then you can just lift the roof into place. But in the logic sequence of things, foundation, walls, and then roof, and that. So great care taken to estimate the approximate completion time for each activity. So we worked it out and say, well, if we stick with we assume the foundations are already in, that's the first activity. Then following the precedence rule, we need to build the walls. Then we might say, how many blocks? So a quantity surveyor, one of your team will say, well, we need 5,000 blocks to build the house. Then you can estimate how many people you need to build, without let's just say getting in the way. Let's just say we stick with the 5 people, that's 1,000 blocks per person. And then say how many blocks can they lay between them per day. Let's just assume they can lay 500 blocks. As a group of 5 people can lay 500 blocks per day. So now we know that it'll take 10 days to lay 5,000 blocks. Okay. So now we have a time activity. Then we say, what's the cost? Well, we pay them €100 each per week. So that's, if we take 5 working days, 10 days, and we pay them €100 each, that's €500 per week, so €1,000. That's cheap labor. But so you see how now you're able to put a cost on, because the going rate, so let's say €500 each per week, so that's 2,500, so that's €5,000 as it happens, over 10 days working to put up 5,000 blocks and so on. So you're following the logic of my house building example. So the schedule, so we say we have 10 days, it's going to cost us €5,000. We have the 5 guys, we have all the equipment they need, cement bags, mixers, shovels, trowels, whatever, and depends on the precedence relationship. So all of these guys are ready to go once the foundation is in and ready and dry, and then these guys are ready to move on. There is no point in bringing them in a week earlier, because the foundation might not be complete, and so on. Now I know you're probably saying, geez Mark, this is very basic, you're stating the obvious. Nevertheless, it happens, getting a sequence, and sometimes you try to schedule, because you're using them in other areas, you have to make sure that the other work gets complete before you can bring them across to build this house. If there's a delay in this other house or this other construction site over there, these guys are not free to come to you. So now you could be sitting there with foundations for 2 days, 5 days, and nothing is happening. And that's a waste of time and money. So getting the sequence and getting everything to flow as smoothly as possible, that's your task as a project manager. So you might have to go to the other house where they're already working and speed up, say, because by Monday you guys have to be working on this new house over here, so we need to finish up and so on. So what do you need to do? You might have to say to them, you need to work over the weekend to complete the work that you're doing there, such that you can come to this new house on Monday morning. That's a cost on that house or that building or construction site. So straight away your costs have gone on, such that you stay within time in your time frame. See how this all comes together. So a Gantt chart, that's just a way of representing, and developed by this guy back in 1910, give or take, thereabouts. And so it's a different color codes that can be used to track the performance while the project is in progress. So you could have a sequence of colors for foundations, walls, and roofs, and so on. So it's and this is what it essentially looks like. So you can see here, on week 1 to week 3, in this case, you would have, stick with me on this one, 1 to 3 might be the foundations. And then on week 4 and 5, that could be the walls, the 2 weeks of the walls that we're talking about. And then on week 6, as you can see here, if I bring my mouse over to the thing, so this could be the foundation, these could be the walls, and if you look down here, I'm jumping all the way down here, this could be the putting the roof on the house. But of course, you have other things going on here. You have all this stuff going on. That could be working on the outsides, getting the grounds ready, getting other work done, preparing part of the roof for this week. This could be I don't know, some other manufacturing, getting the kitchen units and all the panels, internal workings of the house ready for installation. And this might be, and this last part here. So we have the foundation. Oh, sorry. Yeah, the foundation, the walls, and the roof down here. Okay, and these are the electrics and plumbing going on inside, preparing all these for final plastering and all this sort of stuff. And then the final part here might be where you're doing the final fix, putting in all the physical light switches and doing the painting and installing the final parts of your kitchen and so on. So that's a logical sequence of stuff. But in this now I can kill a couple of things or elements. So first thing that needs to be done, second thing that needs to be done, and the third thing. These would be considered to be on the critical path. Now technically you could have some of this on the critical part, that some of these activities could start, that you have to wait until you have the roof on and so on, but you can prepare some of the stuff, and that might move out slightly or back depending on how quickly you get the roof on. But here's the point: foundation, they start exactly when the foundations are complete. We start immediately onto the walls, and when the walls are complete, we start immediately. So if that moves out, if it takes an extra week to build the walls, then you can't do anything. So this must also move out. That's important. That's what we know as critical path analysis. So if we can reduce this, so for example, if we could find some way of taking half a week off the walls, in other words, we can complete it in half a week, then we can bring the roof back to here, which means we can bring everything. And in project terms, when we talk about reducing any of these elements or activities on the critical path, that's what's known as crashing the project. Okay, it doesn't mean destroying it, it just means that we can condense, we can reduce the time if we can do this. Now, there can be any number of reasons that this might happen in reality. There could be some new technology comes out. I saw a machine there the other day that will lay blocks 3 times faster than a human being or something like that. A machine, it was just phenomenal, laying these red blocks and it just boom, 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 boom. They're around a couple of years, but robotics, so they're exceptionally powerful, so to speak. So one of these could be, your company might have invested in one of these, and therefore we might be able to reduce time. So that could happen. The machine was delivered just about as you were starting this part of this house build. So you put the machine in place, and bang, it does it a lot quicker. So we've been able to crash the project, reduce the time, and so on. So these are the kinds of things that can happen to your Gantt chart. Network diagram with arrows, and so it's just and arrows and circles creates a display to display a sequence of activities within a project. So an activity on a node approach network diagram, we'll see one now shortly, that shows each activity as a circle or a node and connects them with arrows into other nodes. And activity on arrow is the, as I say, AOA convention. So a network diagram in which each activity is represented by an arrow, and the nodes are used to show the beginning and end points. And this is what they look like here. So activity on node. So we do this activity, and then we feed into this activity. Or in this case, we start here and we do this activity, and we output our activity here, and that activity then becomes input, or the output becomes input into activity B, and so on. So we start here and we build the foundation. Foundation is done, then we go and build the walls, and then the walls are complete on this activity. Then we could continue it down. So it's just another way of representing the information. There are different ways or circumstances you might use it. For the most part, we use Gantt charts. But for example, in transportation, you might use this, or in production process, you might use activity nodes to show sequences of processes, because fundamentally what is manufacturing operations? It's input, transform, output, and that's the activity, an arrow type approach. So we do something, we have inputs, raw materials, we transform, we carry out some process or action on those raw materials, and we end up with a subcomponent, which is an output. So it's a different way of representing, because Gantt charts might not suit that type of environment, the production process. If you're setting up a new production line, for example, you might use the activity nodes or network diagrams, as we call it, and also in transportation. And this is, it might be another way. So, to a diagram for a Sunny Beach resort project, for example. So you have these activities, and you can see there's really what's happening here is now you begin to see these activities, and before you can do D, you have to have A done, and B can start at the same time and feeds into C, which then feeds into D. And in any case, you see the sequence here. So this one, J, can only be done after I is done here, and so you begin to see a relationship. And then, but once we have all of these activities done, then we have the final output deliverable as such. So So you could have the activities on here, or these themselves could be the activities, and they feed into this activity set, and then that feeds into this activity set, and so on and so on. So as you can see, it becomes a little bit probably a little bit more confusing to read than a Gantt chart. And majority of people know how to use, for example, Microsoft Project, and you can build in all these presets and use a Gantt chart. Now, as far as I remember, it can create a network diagram as well, but it's much, for us mere mortals, it can be easier to look at the Gantt chart in terms of the activities and precedence and sequence, and how we can adjust any of these. So it's an algorithm scheduling activities within a project for the fastest and most efficient execution. So it says an algorithm, but essentially it's quite simple. As I said before, you have to put in the foundation, build the walls, and then build the roof. Okay, and that's that's the mental algorithm, because we know it makes sense. And similarly, if you want to build a car, you have to do so many pieces first before you can actually do the final construction and manufacturing, bring all the pieces together. Now they're all going together at various stages during the production process, but ultimately the output is a car. So critical path within a project takes the longest time to complete. So what are those activities that need to be done in sequence that are absolutely important to the project, and from the time we start, put them in sequence till the last one is finished? That's the overall time to deliver that project. Okay, you can't see both my hands. That's the overall time. So if you can change any one of the sequences inside here on the critical path, you can either shorten or lengthen the project out of in terms of time. So what we do to help us, to give us some little bit of scope, or not scope isn't the word, I shouldn't use that word, some flexibility, we build in what's known as slack. So we might say, in the instance example that I talked about earlier on of the block layers, and we say that we build 500 blocks per day, 5 block layers, and so on, 2 weeks. Let us just say that if we wanted to build in a bit of slack, we might say, well, that's 2 weeks, 5 working days. In there we have 2 additional days, so we have 7 days. So we might say we have a 7-day working week. Or instead we might take an extra 2 days into the 3rd week and say, just in case something goes wrong, we have 2 days. So we might plan it over 7 days, over 12 days instead of 10 days. Okay, that's just to give us a little bit of maneuverability in case it might only be a day. Whatever the case might be, we build in slack, and it gives us some. So if we do this on all the items on the critical path, then we know we have a little bit. So we might gain some time in this sequence of our parts of the project. We might lose some time around this part of the project. So on averages, we might be maintaining the same overall time. Gains, losses, and that's what project management, that's the whole point about monitoring and control, but only when you have the plans in place first, that you give yourself that little bit of, as we say, headroom in the project. So we have what's known as the earliest start time and the earliest finish time, and the latest start time and the latest finish time. These are just parameters. So how quickly, what's the earliest that we can start with? It might be immediately after the day the foundation is put in, and we calculate out 10 days or 12 days, 10 days, that might be the earliest finish time. Okay, or we might say the late start time might be 2 days after we put in the foundation, and then the latest finish time might be 12 days, allowing for slack when we complete the task. So they're the 2 kind of windows using this approach. But in any case, we use these as ways to give us a little bit of room, additional headroom. And this is the way we have of representing this. Earliest finish time, and we use, if you're looking at the node diagram, sometimes you'll see these inside here. We put in a time. Well, it might be a date or a time in the clock if it's been done within 24 hours. So we put in a date. What's the earliest start time? What's the latest start time? So we might be starting at, the earliest start time might be on the Monday morning. The latest start time might be on the Wednesday morning. earliest finish time might be 2 weeks later, which might be the Friday evening of, might be the earliest finish time, or the latest finish time might be the following Tuesday evening. If we think of the 2 days that we're adding in. So you see, so these, and we put those dates or times into give us an idea, so we can see that we have a little bit of flex here. So from the earliest start to the latest finish, that's technically our slack time. Okay, we have those options, and we might use those to calculate all our times in the project. Earliest start, latest finish. That gives us a buffer on all of these activities that we're doing. And fundamentally, then at the end of all the project, we say, well, we can cut back some of the latest start time to or finish time to earlier finish time, and so on, and reduce the project. So it gives us this maneuverability, but it allows us to swell and contract during the project execution to keep the project on track. Are we doing time wise? Oh yeah, we're doing well. So the cost and time trade off, and this is fundamental in any project. So just let me take a quick mouthful of cold coffee. So sometimes the most efficient schedule is not sufficient for meeting the customer's needs. So the scope of the project may need to be changed for additional resources, or additional resources may need to be assigned to speed up the project itself. So you would have had a plan. We'll stick with our house plan, where the you have 5 guys, 5 block layers to build 3 walls, and you've given them 2 weeks. A simple cost and time trade-off there might be, if, for example, you say that the roof was going to be coming in 2 days earlier, although the final construction woodwork of the roof was coming in, you might say to the guys that we need to complete the block not in 10 working days, 2 weeks, but we need to have it complete by the Wednesday evening. So we have to shave 2 days off that. So logically, we would say, right, can you come into work on the Saturday and Sunday? Overtime. So you might save, you saved, you've cut 2 days of normal pay off the project by getting the guys to come in on the Saturday and Sunday, but you would have to pay them maybe, let's just say, for twice their daily rate. So the overtime. So you've reduced the time, but your cost has gone up by a particular percentage. And this is what we have. And you might have to say to the house owner or the builder of the thing, say, yeah, we can make that, we can reduce that time and have the walls built in time for the roof, but it's going to cost you more. Are you willing to pay that extra cost? They may say, yeah, it's important to us because we need to sell this house and so on. They may do that. Or they may not. They may decide, sorry, this is outside the budget. We can't do that. Therefore, we can't reduce it. That's the best way of describing how these two fundamental elements of cost and time trade-off works. Okay. And here we see, I mentioned to you already, crashing a project for identifying the lowest cost approach for reducing the project. So we might look at, without paying overtime, these are the earliest start and earliest finish times, and if our latest finish times. Beg your pardon, because you build in a little bit of slack. You might say, well, we could take a little bit of time off this and come close to the earliest finish time instead of the latest finish time. So remember, we built in this buffer, and you might be able to crash that project, or you might be able to get more experienced block layers who actually, instead of laying 5 blocks per week, 500 blocks per day, they might be able to lay 600 blocks per day, and that could crash down. So getting more experienced and faster block layers in that might help you to reduce or to crash the project. And things like having all of the roof construction completely ready to be lifted onto the roof immediately. These are all ways of crashing the project, and without having too much of an impact guys will be increasing from 5 guys to 6 guys, running the risk of people getting in the way with a little bit, but you can speed up the project. That might be a way of trying, but that increases the cost. So we look at, well, do we get more experienced people or do we go with 6 people and so on? So you have to trade off. This is the whole point about this, looking at best combinations. Now, I'm not going to run down through all of this, but you can experiment with this example as well. So it will take a bit of time. The simplest way would be you could put this into a spreadsheet and calculate out the crash cost and the savings and cost per week of the project. And as you see over time, an additional cost versus duration. So we see over time we can reduce costs and so on. But as we move in the project, essentially additional project cost versus duration. So if we increase, in using the previous example, if we take longer time, then we can spread the costs out over more areas, so we can reduce the cost, but it'll take us longer and so on, technically. So the PERT approach, how are we doing time? 20. Now, I'm about halfway through. How would you feel about taking a quick coffee break? 7 minutes of a coffee break.
Yeah, okay.
Yeah. Okay. Okay, folks, we'll pause it here and just take let's see, what time have I got? I have 13:40. Let's say 13:52. I'll be back on air. How's that? I just need to, because I'm talking so much and Doug, I need to get some lubrication. See you in 7 minutes.
Okay, see you later.
Yeah.
Okay, so we're back again, folks. How are we all doing now again? Right, have a coffee with me. So, the PERT technique, and this is Program Evaluation and Review Technique. That's what the PERT stands for. So, if we look again at the project schedule, so it's another variant of this earliest start time, latest start time, and so on. And what we look at here, we call it the optimistic time. So the minimum possible time required to complete an activity. And then we have the pessimistic, the maximum possible time. So worst case scenario, best case, worst case scenario. And then we take the most likely and then the expected best time of the best estimate of the time required to accomplish an activity considering potential impact. So we allow for a little bit of risk and so on. So these are the timings we put into a project: the optimistic, the pessimistic, and in between then the most likely time and the expected time. So these two times here, the best estimate is of the time required to accomplish a task, assuming that everything proceeds normally, and then the expected time, if there's some elements of risk. Let's just say in the house building, while the guys are building, the weather changed, or you ran out of water temporarily, you had to, or there was a leak in the hose, and someone hit the hose feeding water to mix up the cement, and that could cause a delay. But in any case, you might factor in these and say, what if, what are those? And this is the whole point when we're looking at projects, when we're estimating times, we look at, are there issues potentially, are there risks in any of these activities that can cause a delay, and how can we keep an eye? So we might say, well, we better lay these pipes. We might not have laid them deep enough, and as a consequence, someone hit a pipe and affected the water supply, for example. So sometimes we even though we think about them, things can happen, and that's what this part is essentially describing. Best, worst, and most likely, and we try to gauge. Now, an important point around this whole area, this is all relative to both related to planning, controlling, and monitoring the project. So in the planning phase, when we're trying to estimate all of these times, and that's the core work of a project manager, and knowing the business you're in, so you would have an idea, you'd have a reasonable idea, and so on. But unfortunately, everything is not as straightforward as that. Sometimes we're in very, very complex environments, and the project manager might not have the knowledge or the experience to estimate the times and so on. And that's where you might need some technical support. So oftentimes in very complex projects, and technical project manager as an assistant. And these guys are highly expert in all aspects of the technology and the product and production techniques and so on. And they would give you, well, under normal circumstances, this is how long it could take. And so, but we have to be careful that that such a technical person doesn't operate to his standard, because not everyone might be of that expert standard. So people have various levels of competencies. So that technical expert should give you broad, optimistic and pessimistic levels, and then we work out. And oftentimes we involve the people. Well, how long do you think it will take you to do this task, and how long will it take you to do this task? And again, being aware that sometimes people, I want an easy job here, so I'll give a long time. I'll take, instead of taking 2 days, I'll make it 4 days. And someone else might say, oh, I'll do it in a day and a half, and they might be stretching themselves a bit too much, and in actual fact, it's going to take them 2.5 days instead of 1.5 days. So you have to be careful when we're doing this. So that's all part of the upfront planning, and that's so critical in the project. As I said, 80% of projects fail in this planning phase. The activities that need to be done and the estimations, and these are the reasons why projects technically fail in terms of hitting their targets and time, cost, and scope, because of the planning was not detailed enough, or it was too optimistic or too pessimistic, and so on. So getting it right, and over time you build up the trust with the individuals involved. Saying, yeah, well, he's delivered on time, and we put him on this job because he's good. He's delivered previously in other projects, and so on, so on, so on. So getting this right at the start, and when you have all this done, and this is the challenge, you have all of this done. And this is a really important point. You've gone through all the steps, you've all the activities, you've broken down the structures, you've talked to the people involved on your team and gotten estimates of time and so on to take these. You've agreed that someone says, it's going to take me 4 days, and he said, well, okay, I can do it in 3 days. I was just taking it easy, and for argument's sake, let's just say everyone and all the times are happy. You've agreed these times with the individuals, and they're happy, you're happy, and you have a plan. You have your plan, and say, right, job done, have my project plan done and my feasibility phase done. I know how much this project is going to cost us over the next 6 months, and and it's going to take 6 months, and this is what we're going to deliver. And you bring it to your project sponsors. Could be the directors, could be your customers, and or whomever is paying for this, and say, sorry, Mark, we need it done in 5 months. And you, as a project manager, this is really important. You've got to say, right, guys, if you want this done in 5 months, there are 2 possibilities. We either change the scope, reduce some of the outputs, the deliverables, and we can shave off 3 weeks off it. And they'll say, oh, no, we have to have the full scope, and so on and so forth. Either that, or we're going to have to put more resources on, and it's going to cost extra, and we're going to have to reconsider some of the structure of the project to be able to deliver in 5 months. Or you say, it's not possible to be done in 5 months. That's why you can only be in that position when you have done this detailed level of planning, and you are confident of the numbers you've produced. That's your job as a project manager. Most important. And you have to be able to stand your ground. You have to be able to say to the guys, sorry, this can't be done in 5 months. The only way we can do this is reduce the scope of the project. And you have to, and when you present the logic of your plan, say, this is why, and so on and so forth, you've got to be able to defend the plan. And you can only defend the plan if you're confident in what you've put together with your team. And they'll appreciate it for you, because if you come down and say, sorry guys, we have to deliver all of this now in 5 months' time, they will look at you and say, forget it, Mark. There is no way we are going to be able to do this. That means we're going to have to come in on weekends maybe to try and reduce that. I'm not giving up my weekends and so on. You might turn and say, okay guys, if you're willing to give up several weekends, we can take 3 weeks off the final date, but we pay double. And then you might go back and say, we can consider doing it in 5 weeks and 5 months and 1 week. We can't bring it back to 5 weeks if we use weekends, and that's under a condition of a higher rate of overtime and maybe a bonus. So So it's going to cost you extra to deliver this in a shorter. And they say, well, what about the savings of the 3 weeks in terms of salary and that? You might actually come in or trade off the salary saving against the bonuses, or it might be that the bonuses and the overtime are costing more, and you leave it to them. Which is it, guys? You choose. But these are the only options available to us. That's a good project manager. That's a guy worth his weight in gold, so to speak, because but he's not making the decisions based on on off the top of his head. Some project managers will do that to try and impress their clients and their bosses, and then come down and tell the guys, we have to do it this way, otherwise we'll all be fired. Bad project management. So you have to have the trust of the team, and you have to defend the plan, and you can only defend the plan when you've done the homework up front. And if you do it up front, everything runs relatively smoothly after that. Changes in scope can still happen, but I'll show you techniques of getting around, or how to manage changes in scope effectively with the team support. And I'll show you techniques in that shortly. Sorry, nearly did something wrong there. And that's this. Oh, here we are. So this is just another way of representing the time periods. The earliest finish time, the latest finish time being the green one here, and then the blue one. And of course, we try to go for the bell curve in the middle. We'll try and get somewhere in this region to remain so. So this could be 6 months plus 2 weeks. That could be 5 months plus 1 week. And here is the original 6-month plan that we're aiming for. So we're going to be somewhere. So you will be presenting that to your management. This is the best case, but this is how much it'll cost us. This is the worst case, and this is how much time it'll take. And this is the most likely type of finish. So we'd say a week before the 6 months or a week after the 6 months, depends, whatever the curve represents. But it gives you an idea that you have some level of flex in your project. So two commonly used techniques are the resource breakdown structure and resource leveling. And that simply means, the standard list of personnel are required to complete various activities in project, all the people. And of course, to reduce the amount of fluctuations in day-to-day resource requirements. So in other words, when you have, we'll take our 5 block layers. You want to make sure that they're working from, let's say, 9 o'clock in the morning till 6 o'clock, and they deliver 500 blocks. That's the expectation. That's the norm in this. But you don't want a situation where they're not fully utilized. So in other words, they're finished their, if I suppose it, 500 blocks per day, and and takes 5 days. That's 2,500 blocks for 5 days' work. If you found, for example, that they finished in 4 days, then you have a whole day where these guys are not doing anything. So, and in terms of a resource, you might move them onto another site to finish out some work there, so that you're getting value for what that you're paying them for. So, or you don't want to have certain guys laying 120 blocks per day, and the expectation is only 120. That's overloading them. So we try to get the levels of work. So don't overload a person. And it can happen in a project where, such and such a guy is really good, and I'll give him all the hard work and so on. Sometimes they like it. They like to have that, but you can tire them out. You can overutilize resources, and this is why we have to be very careful of how many tasks we assign to people, because there's only so much time plus their abilities that they can deliver on. And if you push that too high, if it's not leveled, then you can exhaust people, and they can go into burnout essentially. So that's why we have to be very careful at the pace and so on and so forth, and the amount of work that we're doing. And of course, we don't want to give them an easy time. We don't want to give them time that they have half the day off either, because they become bored and they might go off and so on. So making sure that they have enough activities to complete their 8-hour day for all intents and purposes, that you don't overload them and so on and push them too hard. And that's where you need to know your staff, and you need to know the activities and so representing all of these resource requirements in multi-project environments, so you can see how you need them at the very start here. So if we look at the total resource requirement over a given period of time for all these different projects, you can see that on average we're keeping people pretty occupied. So as this project begins to ramp down, for example, we're beginning to ramp up this project, and this project is ramping down. So eventually, all these projects are beginning to close down. So as you can see, as some projects are closing down, more people. What's happening here is that people are being transferred from one project, so they've completed their tasks. So the block layers, as they begin to complete this task, they might be assigned to another task over here and start building this house. And as they begin to come down here, they might move on to the next house when they've completed a task. So overall, these block layers are going to be fairly constantly busy laying blocks over the period of 6 or 7 months, building several houses. In other words. So getting that sequence, so if you're building a housing estate of 50 or 500 houses and so on, you don't need to have 1,000 block layers. You might just have a crew of 40 or 50 block layers, and you start in one house and then you move on to the next house and the next house and so on and so on. That's how it works. Okay. So project management software, now I'll fly through these because they're pretty straightforward. We do have all these, but the most common ones would be Microsoft Project. Now there's a whole range of other online projects. In actual fact, you'll probably do it in the project when we look at the Lemming case study. I will show you. We use Excel, and I've been using this for a number of years. This example with certainly with you guys, and with with my MBA students when the full-time MBA, or not full-time, the executive MBA program was running, and we use Excel, and we use it in previous, even to be able to construct Gantt charts in Excel. It's pretty easy to be honest with you. So you can actually, if you change times, you can actually see your bar moving and all that in real time, and constrain it and subsequent tasks. It's relatively easy to construct, and that's fine for small, simpler kind of tasks. But Excel wouldn't go beyond unless you want to spend inordinate amount of time constructing very complex versions of it. But why bother when you have that becomes inefficient when you will have the likes of Microsoft Project. And of course, you can export all your data from Microsoft Project into Excel and create all these wonderful graphs and show targets and this, that, and the other thing. So we have a lot of software available to us. And as you can see here now, some of the reasons why we use these techniques and all this software, because we've projects that are scattered to the four corners of the globe, to use the expression. Back in the 80s, we had Ericsson's system, for example. It was called PROPS, Project Management Processes, basically. And it was a kind of a U-shaped thing. But we were in at least in 3 continents at any point in time, working on major projects, and you'd have project teams in different countries and so on and so forth. So we would have a project manager, could be in Ireland, he could be in Sweden, Germany, Australia, and they would be gathering all the data. So how do we do this? Because we had software, we had our systems already set up, and we had our own internal systems, and it was a very comprehensive system. In actual fact, Microsoft, was it IBM, at one point at a global conference, they wanted to license Ericsson software, Ericsson's methodology. It was that good. But likewise, Nokia had systems as well. And the reason why they were so advanced, because in the telecoms and high tech and so on and so forth, these systems were evolving quite rapidly, and people could see the validity of using those techniques and methodologies in other industries, and indeed in their own industries, and say, well, that's a new way of looking at it, and so on. So we do have, and again, multifunctional project environments. So you'd have a sub-project in one country, which is a part of a bigger picture. And, for example, back in 1992, a number of us were brought over to Germany to work on the first digital GSM system. In other words, the mobile phones that you're using today, we built those systems back in 1992 to 1994, or are several companies competing with going from the old analog mobile phones to the new digital systems. And we had sub projects in I think it was about 18 different countries, all contributing to the overall. And we delivered it within 2 years. It took us to put this all together and then launch our first digital mobile phone system, hence GSM. And the rest, as I say, is history. Now it's all data, and we've evolved from pure simple digital phone calls and sending simple texts to now today where we have 5G networks rolling out, which are just huge, high broadband, high capacity data transmission. Obviously, that's where it's been going for the last number of years. So why do projects fail? And now I mentioned a number of them already, and then project risk management and why do projects succeed. So some of the failures, financial risk, even with careful planning, it's not possible to anticipate everything, of course. And we try to be as careful and we try to preempt and guess, do all sorts of scenario testing to mitigate risk, but things happen. I mean, the obvious one at the moment, who could have seen COVID and how that affected everything? Look at the impact, for example, on the construction industry. The stop, start, say nothing for all the other industries. But in any case, it's an example of things that can happen. So, was it 10 years ago, 12 years ago? Jaqen, which was the Icelandic volcano, and how that disrupted businesses and people's travel and so on and so forth. And the knock-on is, well, I'm only working on an electronic project here, but you might have had to travel to various locations to work on that particular project. That's all cancelled. So now we have to make alternative arrangements and the impacts of those, and so on and so on. So things happen. Working on a project to build a new car production process, and there's a strike in the French air traffic controllers, which are obviously going on a strike. That can impact, and you can't see. So we kind of look back in history and say, well, the probability or possibility of something like that happens. And the French they have a reputation for having air traffic control strikes. Therefore, we might have to look at alternative ways of getting our components delivered to us, and so on and so on. So all these things can happen that are totally outside our control, and that's where really effective project management. It's not so much managing the normal stuff, but the abnormal stuff, and trying to protect and keep your project protected from as many of these external influences as possible. And of course, there can be internal influences as well. And we say the 4 categories of risk: financial risk, human risk, supply, and quality risk. And if you look, financial risk, if you run out of money, and if I use the house example for continue on that one, you might find that by the time you get to the roof stage, that you've blown your budget for some reasons. Maybe raw material costs have gone up, labor, or the government introduced new pay rates and increased your labor costs, and you had to pay all these, and you run out of money to complete the final part of your project. What do you do? Do you have to borrow money? So it's and the financial risk of something happening, or interest rate changes. Let's just say you're working and you have to fund the project through bank loans or investors or whatever, and the interest rates change, or the capital becomes more expensive, and you might not be able to keep up with the interest payments, and you're eating into the profitability of the project as a consequence. These can be the financial risks that you can run into. It could be anything causing these. Human resource, people getting sick, people leaving your organization, leaving your project team, people being taken off your project team because there's more urgent work needed elsewhere, and as a consequence, those guys in your project, some of them or one of them or all of them, have to be taken off and your project suspended. These can be the human resource type risks. Of course, supply. Any one of your suppliers could go out of business, and that's why we have to do a due diligence on our suppliers to guarantee that we get the product. So, for example, in the case of the roof that we're talking about, that we get the roof manufacturer of the trusses or the prefabricated roof, that they can deliver on time, and that they can deliver to the quality and within the tolerances and expectations, hence the the other side of quality within the project is that if you take risks, take high risks, you could jeopardize the quality if you don't follow pre 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 pre-use or prescribed processes. If you take shortcuts, you could jeopardize the quality of the projects that are not the most simplest. Quality risk is not listening to the customer or the client and understanding precisely what they wanted. And if you take the instance of the house, for example, maybe the client wanted 5 windows in there instead of 4 windows, and they were saying, well, we need more light, and you're saying, okay, we'll put in 4 big windows. In actual fact, they actually wanted 5 windows in there, but not understanding. Now, you could say blame the customer because they weren't explicit enough and so on. But if you had actually talked to the customer, now we can increase these size of windows, and they say, no, those windows are too big. Could we put in a fifth window? And say, yeah, we can put a fifth. Now we're clear. So delivering unexpected, that's a quality risk, in terms of not listening to the client or the customer and so on. So there's a whole range of things that can cause quality risks. So as I say, we need to put a risk assessment plan in place. How am I doing on time? I'm lying. So the severity. So we literally categorize the impact of the risk. What if? And that's all we do. What if scenario testing. The percentage of the project scope will be affected by a particular problem. So if particular raw components or materials become non-available, then certain components might be delayed because you have to go to another manufacturer or find an alternative material to use. That can be a problem, and then we categorize this: is this a major risk or a minor? And then we look at the probability of this happening, chance of that happening, slim to very high, and then of course the timing. At what point in the project? So when does it become critical that we need to know? So if for example, our supplier tells us at the start of the project, and let's just say they were supplying the wood to make the roof, and let's just say towards the start, the supplier comes in and says, we may have a problem with this particular type of wood. Our supplier of that particular type of wood is finding it difficult to source it. You might say to your roof company, can you find an alternative supplier? And so now the whole point is you need to be monitoring their activities to make sure that they come along to you, and when they're ready to start construction, say, yes, Mark, we've now found an alternative supplier. We still have the original guy, but we have a backup plan in place that if they run out of that particular type of wood, then we can use this other person. So we will be able to deliver the roof trusses onto your project site on time. And so again, part of the monitoring control, it isn't just about your own project, but also you might have to manage or be at least informed. So timing, you need to have those guaranteed on your site on the 9th week to be able to put them onto the walls, and that's you work back from there and say, as you're moving closer and closer, and if there's no progress, if there's no alternative supplier, the risk begins to get higher and higher if you can't find. Now it may not happen, but you identify and say, well, we're on 2 weeks off here, and we need to have a guarantee that these roof trusses are being delivered into us. Therefore, it becomes a bit of a panic. So you take all these, and then dynamic risk. As project proceeds, will the probability of the problem occurrence increase or decrease? And that's the kind of thing as it's getting closer and there was no decision on the alternative supplier. Is so up to a point it's a kind of a constant, and then it becomes more dynamic. It gets higher and higher, so you're beginning to worry more that the particular roof trusses will arrive on time. And 2 weeks before the project, everything is signed, agreed. Yes, everything is fine. And they say, yes, happy days, we have now guaranteed. And that, but up to that point, it was getting closer. It was getting dynamic, and you could almost, I would say, equate the dynamics of the risk with the levels of your blood pressure rising. Okay, and this is just a risk map, where we identify those critical elements of the project where there might be a higher probability of risk happening or not happening, and we produce this. And so when we sit back and we say, well, in the house build situation, on what did I say, on week 9, we have this potential risk. Right now, so I have other priorities, getting the foundations in and getting the walls built, and then, but nevertheless, it's a risk. So you know what's happening. So you keep in touch with your suppliers to see that as you're getting closer, you can the risk is either staying stable or becoming more serious, or it becomes no risk. So we often use this sequence of red, amber, green, for example. Red being a serious risk, and then we drop it to amber because we were getting more guarantees, and we can see that the supply of the different types of wood is becoming available. And green, then we say, yeah, everything is in place, so it becomes not a problem for us. It was identified as a risk, but nevertheless, it's not now a risk as you're getting closer, or it's the worst. It's becoming red. It's becoming a serious risk, which has a potential to delay the whole project because it's the roof, and that's a serious risk element. So we analyze the potential of risk. Once the risks are presented on the scale, we develop a prioritization list, and then we develop potential upside for the project, again by the project manager, and then assign the team members the responsibility for monitoring the signs of potential problems as such. So these are just, it's an example of a risk plan and what we need to do to put in place so that everyone can remain somewhat calm during the execution of the project and not, create too much. A risk register is just another way of calling it's a dynamic document. So remember the one that I was saying that red, amber, green, that's all it is. We look at the risks. So, and once we're past them, then we're green, we move on to the next. So they might be categorized as red or as we're getting closer, or they might be red from the very start because this is something we need to watch very, very, very closely. And then again, why do they succeed? Back to my main point of project planning. Clearly defined goals, what absolutely is expected of the project team, what your customers expect, and what needs to be delivered to the customer. Tying down the scope from the very beginning so that everyone understands this is what we're doing over what period of time, and these are the deliverables. And are there clear milestones along the way? Yes. Here's the foundation. Here are the walls. Here's the roof. Here are the clear milestones. So we have to have this done by then, this, and so on and so on. So we break it down into these work breakdown and generic phases of the project, and then we have the final fit out, and tidy up, clean out, and so on to the end of the. So you might not need so many people on site, hence you get this curved graph. More people during the build, and towards you get to the end, you might just have the final painters coming in to do the final touch-ups, and then an inspection of the house. You might only be talking about 2 or 3 people, as opposed to 5, 6, and 10 people on the site at any one time previously. So project manager's ability, and this is why I say in certain instances, project managers can be worth their weight in gold, because they're experienced, they are good at planning. They're very effective at monitoring and controlling projects. So it's a skilled and experienced project manager, have a plan and a budget, and so on and so on. And can the project manager motivate the team? Now this is where I will give you a video clip next week of some of the discussion around leadership, and it's as equally important in the context of a project manager. And I'll let you have a look at that next week. I'll load it up onto the link onto Moodle for you, along with 1 or 2 other bits. So having that the project champion, to use that other expression, but a good project manager is extremely valuable in an organization. Leadership skills, and so on. And then other reasons, having the right team, the right skill sets around you, having people with the right competencies, sufficient training, experience, and so on and so on. They're just some of the examples or some of the reasons there. And top management support. And fundamentally, of course, does the project fit the organizational objectives? And clearly that's important. It has to feed into the overall strategy, the strategic goals in some shape or form, and we can see the linkage there. But also, once you have a good project manager and a good team, getting support from senior management becomes easier because they have trust in the project manager. He's delivered for us before. He and his team are exceptionally good. We can almost let him off and do the project. We don't need to be looking over his shoulder all the time, but he'll give us a monthly report and so on and so on. But in any case, getting that support, and I don't want to delve into the area of it, but it's a question I used to have on my MBA for my MBA students was a quote. There's no such thing as a bad project, only the perception of one. Please discuss. And the answer was quite simple to this. It was simple politics in organizations. And unfortunately, it exists. And where it exists is you might have a project and you say that to deliver something, you might have other people in the organization or even other project managers who say, well, Mark has taken all those resources, so I'm going to give his project a bad name and say, oh, look, his project has fallen behind, look at the risk, he didn't do this, he didn't do that, and they start to talk very negatively of your project and so on. So they create a perception that your project is bad, and if you come in, over budget or beyond time, saying, look, I told you so, he couldn't deliver, blah blah blah. So people can be, in organizations can be that political. How do I get around that, or any project manager for that will get around that? You publish your progress. You state very clearly how you don't give them the ammunition. So clearly communicate, and that's part of your role as a project manager, is to clearly communicate back to the senior managers, back to the organization itself, how you're actually doing your progress reports and your status reports to show how things are moving along. So it doesn't give people any room to complain or criticize and create negative perceptions of your project. It's simple, but it's extremely effective. Project planning. Also, this I've beaten this one so much. It's a good short-term planning, progress measured against the plan, and so on. So planning is critical. As I said, 80% of projects fail due to poor planning in the very early phases. So putting all the effort and detail into the first part of it is extremely important. The next point here, communication. Can team members discuss issues openly? Again, this depends on your leadership style and abilities and the environment, the dynamics of the team itself. This is why leadership becomes so important. The communication, to be able to communicate precisely back to the team what's expected of them, what agreement on the activities, the time taken, and the plan itself. And a word of advice, I would always say, as you produce your progress report, the first people that should see it would be your project team themselves, then the senior manager, because you're acting on their behalf. And you want to make sure that this is the status of our project right now, and we'll talk amongst ourselves as a team. Is everyone happy with this? This is what we're going to present to the senior manager and senior team and our senior management team in the organization. And that's a little bit, how would I say, it can be a little bit, I won't say a problem, unorthodox to do it that way. We've got some project manager gather all the report and run straight upstairs to present the status of the project. No, involve the team to have that strength to say, like, I'm going upstairs to represent you guys on our project, and this is the status, and this is and we have some problems here. Are we all clear that these are the problems? And we've also had some successes here. Are we all happy to agree on these? And people say, yeah, might not be too happy about some of the problems, but it's a fair representation of precisely where the project is. And then you can go and confidently present communications. And user involvement. Do we know the end user who's going to, and essentially the customers? I know, have the end users been involved? Another interesting point. Oftentimes we'd say we get the requirements from the customer and then say, well, there you are. There's your product, or there's your component, or whatever it is. We've delivered a project to you. The important thing is that you might involve and say, look, we've done our planning, and this is how much time and cost of it's going to take based on what we've agreed on in the scope. And the customer would say, okay, I'm happy, yeah, I agree with that. It might be nicer to have it faster, and we say, well, we can do it faster, but only if we have certain other resources, and maybe it will cost you more, and so on. And say, oh no, I'll go with that, with this plan. And going through it, and as they begin to see their product or service or whatever it is begin to take shape, should we say, and you're getting through the execution of this, and you double check, you sure, and they might say, oh look, we've seen another competitor with this other feature, can we build this one in? And you might say it's outside the scope of the current project, and you could consider maybe we can do this if we do this, and this, but it's going to come as a cost or additional time. And the customer say, yeah, but I have to have this new feature included there. You need to be able to say to the project team, or discuss this with the project team, we need problem is that sometimes it means rework, undoing some or a lot of the work you've already done to add in this new feature. And as a consequence, people don't like to have to do the same thing again. You know, undoing something and redo the whole thing all over again or part of it and so on. That's a real demotivator. How would you get around that and say, Mark, do you remember all that code you wrote there for this? Well, we need to put in a new change and it's going to impact your code and there's an urgency for this new feature. And I say, no way am I redoing all of this. And you might say, well, here's a big bonus. Or you can take paid leave for a week or 10 days or 10 weeks or whatever. That might say, well, okay, but because I'm familiar with the stuff, I might be able to get it done a little bit quicker, or it might create some new problems. Nevertheless, we evaluate it. We look at what has to be done and the cost and impact of any changes. And I'll come on to it. As I said, there's to give the heads up, what they're known as, there's two elements possible to facilitate: change requests and exemption requests. And this is a way of allowing us to change the dynamics of the project, whether it's a scope and time or cost, legitimately, but only in agreement with the project team itself primarily, and then agreement with the customer. And I'll talk about that in a later time. And then, of course, the commitment of the team. So when you have highly motivated and are an effective project manager and your leadership skills are exemplary, you can get commitment for the team. And when people, and more importantly, when you feedback the status of the project through the project reports, and because you're involving them, they're seeing that things are getting done. That motivates them. They become more and more committed to deliver on their project. And then the types of control systems that you put in place, they could be simply meetings, or you could have a very tight tracking mechanism on your project management software and getting people to authenticate what they've done and how they've done it and so on. So there's a whole range of techniques or systems or approaches, but fundamentally, oftentimes it's a question of having a weekly meeting or a fortnightly meeting, or whatever the case may be, to get so people can see that yes, we're in control, we know what's happening, we can see how things are evolving and so on. And then, of course, the risk management and the risk management register and all that sort of stuff. So nothing comes as a total surprise to us. We try and identify the risks, and that way we can have, should we say, fewer sleepless nights. We can actually manage to have some level of sanity. And of course, if you have vacations planned during the project, which quite often can be the case, at least you can go and enjoy your vacation knowing that things are not going to go pear-shaped or go drastically wrong while you're on vacation. Everything is, you have control of virtually everything. So that was actually the last slide I have for you folks on this. There was quite a bit in that. As I said, I brought you from the overalls of project structure. I'm just going to drop back to my other screen and hoping all these things are working effectively. And here I am again. So, folks, yeah, that's as I said, there's quite a bit in that. I'll probably appendix it to Part A and remove that concept of Part A and upload this to YouTube, and I'll put timestamps on the different content, so because otherwise it'll be quite a lengthy video, a couple of hours long, and we don't want to do that for you. So you can actually jump to various points on it. So it'll take me a day or so to do that for you, but at least you'll be able to get some key information. As I said, there's quite a lot of stuff inside there. And it is worth going back over, and I hope my example of the house building and so on sort of isn't too oversimplistic, but it very effectively demonstrates all of the concepts that we've introduced you to this morning on project management. And really, everything else now is just layers of this stuff. That's it. There's nothing more complicated or difficult about this whole process. It's a question now that you have all the tools. Now it's a case of putting them into action. So, do we have any questions, folks? Any comments? And I can start wrapping up for you on this. Yep. I'm slightly ahead of time, which is good. Everyone okay?
Yes.
Okay, folks. Listen, I leave you on that one, and I'll let you work on your projects on Thursday, so we won't have the formal lecture, and I'll be actually using those couple of days to start preparing some material and pre-recording material for you for next week. So definitely you will have a lecture on or at least a video on leadership, and I'll take one or two other elements of the stuff and present that for you to look at. I'll keep them relatively short, the video clips for next week. And of course, if you have any questions or if you need any help, just pop me off an email. Okay, folks. Yeah.
Okay.
Everyone happy?
Yeah.
Okay, folks. Listen, I'll